Hello friends. In this video, we are going to study about the statistical analysis of data in the measurement system. Here we will study the various terms like arithmetic mean, median, variance, standard deviation. What are these and how they are calculated in the measurement systems? So let us start with our topic. Now, in measurement systems, there are various types of errors like static errors, gross errors, observational errors, instrumental errors, and the random errors. Now, to calculate these errors, there are some types of errors which can be determined at the time of measurement. But there are some errors also which cannot be determined directly, but we have to do some mathematical calculations to determine them. Okay. Such types of errors, the example of such types of error is the random errors. The random errors in the measurement system, there are no reasons of these random errors. Suppose that there are some small errors which are occurring at the same time in the measurement system. So the accumulation of these small errors, they are going to cause the random errors in the measurement system. Okay, so these random errors, they cannot be determined in the process of measurement. Means while we are doing the measurement, at that time we cannot determine these random errors. So to calculate these random errors, we have to do some mathematical analysis. Okay, so we can say that the mathematical analysis of various measurements statistical analysis of data. So we can define the statistical analysis as the mathematical analysis of the measurements. When we are doing the measurements, we will get different readings, okay? And on that readings, if we are doing some mathematical calculations to obtain some terms, then that is called the statistical analysis of data. Now, under this statistical analysis, what we do? So in the statistical analysis, because we are doing that mathematical analysis on the measurements, and measurement is what? We are taking different readings, okay? So the same reading, okay, like suppose we are measuring the temperature. So the same temperature will be measured again and again, okay? So the same reading is taken number of times, again and again we will take the readings using different observers. Suppose one time observer 1 is taking the reading, next time the next observer is taking, third time next observer is taking. So we will analyze that when we have the observer is being changed, what is the reading which we are getting. So the same reading is taken, but we have used different observers, we have used different instruments, like temperature can be measured using the thermometer also, using RTD also, using thermistor also. So we are using different instruments to measure that value, okay? So we are checking that if we are using different instrument, then what will be the effect on the readings which we are taking. Also, we are different using different ways of measurement, like the method which we are using for doing that measurement, that is also different. Suppose first time we have used method 1, second time we have used method 2, third time we have used method 3. So different ways of measurement are being used. So by using these different ways, like different observer, different instruments and different ways of measurement, what is the effect on that reading? Okay, so what this statistical analysis provide us, it helps us in finding out the uncertainty in the measurement. So that is why statistical analysis is very important. It helps us to determine analytically the uncertainty present in the result of our measurement. Okay. Now, what are the how we are doing the statistical analysis or the mathematical analysis over the measurements? There are different terms which are being calculated. The examples of such, some of them are: first, arithmetic mean. We can calculate the mean of the measurements. Then median, deviation from mean, average deviation, standard deviation, and variance. So these are some of the mathematical terms which are calculated when we are doing the statistical analysis over the measurement. So let us understand that what are these terms and how they are calculated. First, we will start with the arithmetic mean. So, when we are doing different measurements, like as I have said that in a statistical analysis, what we do, same reading is being taken again and again by using different observers, different instruments, and different ways of measurement. So, we are having a set of measurements. Suppose we are measuring the temperature and we have measured the temperature 10 times, okay, by using different techniques. So, we are having a set of 10 values. So out of those set of measurements, the most likely value which is repeating in that set, that is the arithmetic mean. So arithmetic mean is defined as so arithmetic mean is defined as that when the number of readings of the same measurement are taking, means same value is being measured again and again and we have taken a number of readings. So the most likely value from that set of measured variable values is called the arithmetic mean of the number of readings taken. Okay, suppose that we have taken the 10 readings, okay, and from that 10 readings, the most likely value, that is the average value, is called the mean or the arithmetic mean of that number of readings taken. Let's take an example how we denote or mathematically obtain the arithmetic mean. What is the mathematical formula for calculating arithmetic mean? So suppose that we have taken n readings. Okay, so these n readings will be represented as x1, x2, x3, x4, x5 till xn. So total number of readings taken are n. Okay. Now when we sum up all these readings, we take the sum of all these readings, then it will be represented as x1 plus x2 plus x3 till xn. Okay, we have taken the sum of all these readings, and then we are dividing these readings with the total number of readings which we have taken. So suppose that we have taken 10 readings, so it will be from x1 plus x2 plus x3 till x10. There will be 10 readings, and dividing all the sum of all these readings with the total number of readings, that is 10. So that is going to give us the arithmetic mean, which is represented as x bar. Okay, so this is, we have represented that x bar, that is arithmetic mean, is the summation of xn, that is the nth reading, and this n is varying from 1 to n, that is the total number of readings, and then divide them by n, again the total number of readings. Okay, so this is how we can mathematically obtain the arithmetic mean of the readings taken. Now, if the number of readings which we have taken, it is very large, then this arithmetic mean is very close to the true value. Okay, suppose that the true value of a resistance which we are measuring, that is 100 ohms. But this 100 ohm resistance is being measured by different observers. So suppose that one observer is measuring 100.1, another is measuring 100.01, another is measuring 99.9. Okay, someone is measuring 98.9. Okay, so if we take the sum of all these readings and divide them, because we have taken 4 observers, so divide them by 4. Okay, so we will get the arithmetic mean, and that mean is going to be very close to this true value, that is 100 ohm. Okay, so it is being said that if the mean is number of readings taken is very large. Suppose if we have taken 10, 20 readings, then the mean is going to be very close to the true value. But to calculate the mean of such of so many values, or to take so many readings, that is very complicated. So in that case, when the number of readings is very large, instead of measuring the arithmetic mean, we calculate another term which is called the median. Okay. So arithmetic mean was the sum of all the readings divided by the total number of readings. Now the mean is very close to the true value if the number of readings is very large, but to calculate such so many readings, it is very complicated. So instead of measuring mean, we measure the median. So let us see that how we define the median. So Median is defined as for a set of n measurements x1, x2 till xn, we have taken n measurements, and when we write all these measurements in the ascending order of magnitude, that is the smallest number, then the number which is greater than it, like from small to large number. Okay, like the readings which we have taken earlier. Like suppose if we take the examples of these readings, so first of all 98.9, then 99.9, then 100.01, and then 100.1. So in this way, from smaller number to the larger number, when the readings are written in the ascending order of magnitude, the median is given by x median is equals to xn plus 1 by 2. Let's take an example. Suppose that there are a set of 11 measurements. Okay, and these measurements are written in the ascending order of magnitude, like x1, x2, x3 till x11. So median will be given as x n is what? 11. So 11 plus 1 divided by 2. So 11 plus 1 is what? 12, and 12 divided by 2 is 6. So x median is the equal to x6, that is the sixth measurement, x3, x4, x5, x6 till x11. So x6 will be called, sixth measurement will be called the median of the measurements. Okay. Now this was the case when the number of measurement is odd. Okay. Now if the number of measurement is even, then median is given by, suppose that there are 12 measurements. Okay, so n will be equals to 12. So in that case, median will be the sum of, or the average of the middle two readings. Okay, so middle two readings means x1, x2, x3 till x12. So two middle readings will be x6 and x7. Okay, so median is given by, median is equal to x6 plus x7 by 2. So in that way, if the number of measurement is odd, then you have to use the formula xn plus 1 by 2, and if the number of measurement is even, then take the average of the middle two readings. Okay, so that is called the median. Now next term is deviation from mean. Now deviation means that we are deviating, or we are going at a different path from some value. Okay, that is how, what is the difference between the actual value and the value which we are getting. Okay, deviation is somewhat, we define it like this. So deviation from mean means that how by how much value the reading is deviating from the arithmetic mean. Okay, so deviation tells us about the departure of a given reading from the arithmetic mean. Okay, like we are given the readings, we have taken a set of n readings, so by how much value each reading is deviating or departing from the arithmetic mean. So what we will do, we will calculate the difference between the reading and the arithmetic mean, and that will be the deviation. Now this deviation is denoted by d and is given as xi minus x bar. where DI is the deviation of the ith reading. XI is the value of ith reading, and X bar is the arithmetic mean. Again, if we take the same example where we have seen that the resistance is value, so suppose we are getting some mean value and each reading is we know, so that reading minus the arithmetic mean, here deviation will be 100.01 minus arithmetic mean, deviation for third reading will be 99.9 minus the arithmetic mean, and for fourth it will be 98.9 minus the arithmetic mean. So in this way, for every reading we are going to calculate the deviation. Okay. Now, there may be possible that the arithmetic mean may be greater than the actual value of the reading. So there can be, the deviation can be positive or it can be negative. Okay. So positive deviation will be the case when the reading is greater than the arithmetic mean, and negative deviation will be the case when the reading is smaller than the arithmetic mean. Okay, so the deviation can have positive value also and negative value also. Now next term is the average deviation. Average deviation means that we are taking the average of all the deviations. Okay, like for every reading we are calculating the deviation. So when we sum up all the deviations and divide them by the total number of the readings, we will get the average deviation. Now as I have said that the deviation can be a positive or it can be negative. So when we are taking its average, means when we are taking the sum of the deviations, then we have to consider the absolute value of the deviations only. We have to neglect the sign. Okay, whether it is positive or negative, we have to neglect the sign and we have to take the sum of the absolute values and divide that sum with the total number of readings. Then we will get the average deviation. So average deviation is defined as the sum of the absolute values of the deviations divided by the number of readings. So by mathematically we can write its formula as D bar equals to summation of the absolute value of all the deviations divided by the number of readings, that is N. DI is the deviation for the ith reading. We are taking the sum of it, okay, and we are dividing it by the total number of readings. So we are getting the average deviation, capital D and a bar over it. Okay. Now next statistical analysis term is the standard deviation. Standard deviation means that as we are calculating the mean, okay, so how the values are spreading around this mean, that is called the standard deviation. Okay, so in standard deviation what we do, we will take the square of every deviation, okay, and then divide it by the total number of readings. So standard deviation, the amount by which So the amount by which the n measurements values they are spreading around its mean. Okay, suppose that this is the axis on which we are defining our readings, and we are having different readings over it. This is the mean value. Okay, that is x bar. Now suppose that one reading is this, one is this. So around this mean, how these values they are spreading, that is called the standard deviation. Okay. Now this standard deviation is sometimes also called the root mean square deviation. Why it is called root mean square deviation? Because this standard deviation, it is expressed as the first we are taking the square of the deviations, then we are taking the mean of those square deviations, and then taking the under root of it. Okay, so if we write the formula for the standard deviation, it is denoted by the sigma sign. It is equal to, first we have to take the square of all the deviations, so it will be like d1 square plus d2 square plus d3 square. For every reading we are calculating the deviation and taking the square of it, and then we are adding all these deviations and dividing them with the total number of readings. Okay, that will be called the mean of the deviations. Okay, after that we have to take the under root. So sigma will be, we can write it as summation of the square of the deviations divided by n. So it is sum of individual deviations divided by number of readings and square root. Standard deviation is the square root of sum of individual deviations squared divided by the number of readings. That is why it is called the root mean square. Root, we have taken the mean and square. Okay, root mean square deviation. Now, if suppose that the number of readings which we have taken, it is less than 20. So, in that case, the formula for the standard deviation will have some changes. So, if number of readings is less than 20, then the denominator of this equation will be changed. It will become n minus 1 for n less than 20. Okay. Now, in a measurement, if we are getting the value of standard deviation as less, we are getting a small value, then it means that our measurement is very accurate. So, lesser the value of standard deviation, more accurate our measurement is. Okay. Now, next and the last term comes is the variance. Okay. Variance means the square deviation. Okay. In the standard deviation, we are calculating the root mean square deviation, and only if we are calculating the square deviation, then that is called the variance. So we can say that variance is what? It is the square of standard deviation. How? Let's see, because this variance is denoted as V. It is equal to square of standard deviation. Now standard deviation is what? Under root of d1 square plus d2 square plus d3 square up till dn square and divided by n. Now if we are taking the square of this, then this under root will be removed. So V will be equals to sigma square equal to d1 square plus d2 square plus d3 square till dn square divided by n. Now in this case also, if we are having n less than 20, then the formula will be changed. It will be equal to V equals to sigma square d1 square plus d2 square plus d3 square up till dn square upon n minus 1. Okay. So this is the variance. So we have seen that in the statistical analysis, we measure different terms. We do some mathematical analysis of the data, and while doing that mathematical analysis, we calculate these terms: arithmetic mean, median, deviation from mean, average deviation, standard deviation, and variance. And how these values are calculated, we have seen their formulas also, and what will be the benefit of calculating these values. Now let's take an example so that it will be clear to you that how we calculate these values whenever we are doing some mathematical calculation or some numerical is given to us. So let's see that example. So this is our question that in a survey of 15 owners of a certain model of car, the following figures are for the average petrol consumption they were reported. Means that there is a certain model of car, okay, and this car is being used by 15 owners. So how much petrol is being consumed for every car that is being reported in a survey, okay. Now we have to calculate the mean, median, standard deviation, and variance. Okay, so we have to do the statistical analysis over this data which is given to us for the 15 owners. Okay, so the total number of readings are 15. Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. 15 readings are there for us. So we have to calculate mean, median, standard deviation, and variance. So we know their mathematical formula. We have to just use that formula and calculate these values. So let's start with it. Now total number of readings is n, that is equal to 15. Okay. Now to calculate the mean, that is x bar, we have to take the sum of all these 15 readings, that is x1 plus x2 plus x3 till x 15. And we have to divide the sum of all these readings with the total number of readings, that is 15. Okay. So if we add all these terms, that is 25.5, 30.3, 31.1, 29.6, we have to add all these readings. So when we add them, we will get the value 465.8. So divide the sum of these readings with the total number of readings, that is 15. So x bar, that is arithmetic mean, is coming out to be 31.0533. So as I have said in the definition of the arithmetic mean, that arithmetic mean is the most likely value in the total readings. Okay. So 31.0533, it is the value which is repeating itself in these 15 readings most probably. Okay. Now calculate the median. Now to calculate the median, we have to see that the total number of readings is n equals to 15, that is odd number. So for an odd number, the median is given by x n plus 1 divided by 2. Okay. So here n is what? 15. So 15 plus 1 divided by 2, that is 15 plus 1, 16. 16 divided by 2 will be 8. So x median is equals to x 16 by 2, that is x 8. It means median is the 8th reading. So if we see our readings, first, second, third, fourth, fifth, sixth, seventh, eighth. 8th reading is what? 30. So now, here in median, we have to arrange the readings in ascending order of magnitude. That means the smallest value will come first. Now in this, the smallest value is what? 25.5. After that, we are having 28.9. Okay. That is our first reading. 28.9 will become our second reading. Then we are having 29.2 third, 29.5 fourth. Fifth reading will be 30. Sixth reading will be 30.3. Then 30.5. And after that, we are having 31.1. Okay. So arrange the readings in the, here I have forgotten one reading, 29.6 also. So 1, 2, 3, 4, that will become the fifth reading. This will be sixth, this will be fifth. After that, this will be sixth. This is seventh, and this will become eighth. Again, let's see if there is any reading left here. No. So our median is 30.5. Okay. Don't forget that in the median, you have to arrange the readings in the ascending order of magnitude. After that, you have to calculate that which will be the median. Okay. Now we have to calculate the standard deviation and the variance. Now to calculate the standard deviation and variance, we have to first calculate the deviations. Okay, and we will calculate the deviation of each reading. That is given by di equals to xi minus the x mean. Okay, the value of the ith reading minus the arithmetic mean. So suppose that we want to calculate the deviation for the first reading. First reading is what? 25.5. So 25.5 minus the arithmetic mean. Arithmetic mean was 31.0533. So D1 is equal to minus of 5.55. Okay. Again D2. Second reading is what? 30.3. So 30.3 minus 31.0533. So that will again come out to be minus of 0.753. In this way, we will calculate the deviation for each of the readings. So D1 was minus 5.5. D2 is minus 0.753. D3, I'm just writing the values of all the deviations. So just compare these values and use the same formula as I have calculated the deviations D1 and D2. In that the same way, you have to calculate it up till D15. So D3 is plus 0.0466. Okay, because the third value was 31.1 and the deviation was 31.053. So it is coming out to be positive. So I have written the value for the deviations of all the 15 readings. Now to calculate standard deviation, so standard deviation is given by sigma. It is the root mean square of the deviations. So we have to take the square of all the deviations, then we have to take the sum of all those deviations and divide them by the total number of readings. Now here take this, keep in mind that when n is less than 20, then formula, the denominator term is n minus 1. If n is greater than 20, then in denominator we will divide it by n. So here we will take the square of all the deviations. Okay, here deviations are given to us. We have to take the square of all these deviations. Then we will take the sum of all the squares of the deviations and then divide it by 15 minus 1, that is 14. So here we will have summation 126.2326 divide by 14. So when we divide it and then takes it the under root of it, we will get the value 3.00. So now next we have to calculate the variance. So variance is what? Sigma square. So we have to take the square of the standard deviation. It will be 9.00. Okay. So here in the question we were to calculate the mean, median, standard deviation and variance. So we will calculate the mean by taking the sum of all the readings and then divide it by the total number of readings. To calculate the median, just arrange all the readings in the ascending order and then check that what is the total number of readings, whether it is odd or even. If it is odd, then n plus 1 by 2 will be the median. If it is the even, then you have to take the sum of the middle two terms and then divide it by 2. Then to calculate standard deviation, first you have to calculate the deviation, that is the deviation of each reading from the arithmetic mean. After calculating the deviations, take the square of all the deviations, add them and divide them by the total number of readings. Just check that whether the total number of readings is less than 20 or greater than 20 and make the appropriate changes in the formula. After that, calculate the variance by taking the square of the standard deviation. Okay. So here in this video, we studied the statistical analysis of data, which is the mathematical analysis done over the measurement values. Under this statistical analysis, we define the terms mean, median, then standard deviation, average deviation, deviation from mean, variance, and standard deviation. So I hope that this topic is now clear to you. Thank you.